Hi, and welcome to the first video in series about project and game optimization inside UEFN. I want to start this video by explaining what in-game memory is and difference between project download and upload sizes and static mesh assets topology good practices. So let's start with in-game memory. So we have this indicator or thermometer on top of our project inside of Fortnite. And this is actually a random number. This 100,000 doesn't represent anything directly. So it's just a number Epic end up with. So what this current memory usage and what this memory is. So in-game memory, it's actually a representation of primary memory. Otherwise, we're calling it RAM or RAM. And this is a temporary memory where our CPU puts stuff which it needs later to just to process some data. And when it doesn't need anymore, it clears that from the memory. So that's why it's a temporary memory. Same time, this memory is cleared from app any data when this app is closed, or everything is cleared when you restart your computer. And this is a difference between the secondary memory, which is our HDD, SDD, so basically any file saving location where you save and it stays there until you delete it. Okay, so that's a difference. And into our RAM, CPU places stuff which, as I say, like it thinks like if it needs now or it thinks it will need later, because our primary memory, it's much faster than our local disk drive, right? Like even SDD, it's much slower than our RAM. And that's why CPU is placing it there, but it's much smaller comparing to our, again, SDD, let's say. And when we're placing there, we have limitation, and especially on the different devices. So comparing, let's say, high-end PC and mobile phone, there is a huge difference, okay? And that's where this limitation comes, that it's not directly represented because memory is calculated in bytes and kilobytes, megabytes, gigabytes, right? And it's not a representation of this 100,000. And we really don't know exact number. And it basically protects us that our game won't crash on any devices. Because even if you would say, like, I don't care about mobile phones, but Fortnite is a cross-platform game. And we can't choose on what devices players can play. So if player will come on mobile device and your game is not optimized for mobile device, it will start crashing. And I'm not a developer in Epic Games, so I can't tell for sure, but I would be surprised if there will be no system, like automatic system, which would detect that your game constantly crashing devices and your map would be just removed from discovery on totally like closed until you will fix that. So if you will say that I don't care about mobile devices and I will put like lots of high poly stuff in the map, you need at least to make it, let's say it may look ugly on mobile phone, but it still needs to run. And that's super important. And that's why we have this meter. So of course, PC can handle much more stuff, but same time, mobile phones, they can't. And that's why I, again, would be surprised if this meter is more for lower-end devices rather than high-end devices. So it's basically to make sure that all devices can run it. So keep that in mind. And then let's move on to our project size. So in the project size, we have our upload size and download size. What's the difference? So difference is that it ignores everything what you have here in a content drawer, right? But whatever you put in the map, then it will start counting. So in the content drawer, you can have like files for 20 gigabytes. They won't account into here until you will drag, let's say, any file. Like I have these cubes, right? This is custom cubes. I drop them in the map. Now they will count towards this upload size. So everything what's in the map, not only in a content drawer. And we have limitations, so then how much we can upload for the server, because we're doing cooking or packaging our map for the player to play on the server side. And if server will tell that you over that limit, that's it. You won't be able to publish your map, so be careful. And in the future videos, I will explain more how to optimize project size and download size. Yeah, but right now I want to explain what that is. And download size, its difference is this is what our players will download after our server packaged or published our map. Okay, so when it's publishing into state of to playable state, we have this limitation. So this is when player press to play our map, and then more custom stuff you have, longer it takes to load, because it basically downloads that. And all Fortnite, like all these Fortnite assets, they're not counted towards the upload size and download size because they're part of the client already. That's why we have this 70 or 80 gigs Fortnite client, because all these assets are already part of that. And that's why if you're using just Fortnite assets, when player wants to play your map, it loads much faster than, for example, with custom assets, because it doesn't need to download that. It's a part of the engine. Okay, so I hope that's understandable. And you need to pay attention for above, right? So project size and download size, and of course in-game memory. So we will cover in this series of the videos most of that. And I don't want to go like too deep into technical side, but I hope you will understand easier how to develop more advanced maps. Okay, so from here, let's jump into static objects, topology best practices. So in here, I created 2 cubes. And I know this is more on a 3D artist side, but if you will hire someone, you can then ask them how to properly do this. So for example, I have these 2 cubes and they look pretty much identical. And I applied this glossy material because on a glossy surfaces, it's much easier to see some distortion if something basically wrong with our surface. And it actually looks pretty good. But if I will go to wireframe mode, see a difference. Okay, so all this bevel, yeah, so like round edge, it's a part of the mesh, and we have lots of geometry in here. While in here we have empty face, and this is actually not a round bevel or edge, and this is just like 2 edges. And we're doing this roundness in just how normal is calculated. And it's pretty easy to do, but it looks identical. So proper practice is we should only add geometry or triangles where we need them. So it's basically if they're contributing to shape. If you're removing, let's say, these lines, edges, and your shape didn't change, especially silhouette, then it means you don't need them, right? And I saw many models where it looks, you know, like this, especially in the center where you don't need all these details, and it looks like that. In the AAA games, they're using similar topology because they have vertex painting, so they can add with a shader different details. But in UEFN, we still can't do this, and basically we have limited possibilities. So you want to use as low as possible like this, but without sacrificing quality too much. And because one of the things is we have CPU and GPU to care about. On the GPU side, we have more vertices to render. Current like generation GPUs, they can render lots of triangles without any issues. But again, we need to care about mobile phones and let's say Nintendo Switch and lower end consoles, right? So again, if you will add, let's say, millions and millions triangles in your game, and on the mobile games, as it will start crushing, you will be in troubles. And so it's one thing to worry about. Another, it's static mesh. It's a biggest contributor, like one of the biggest contributors to our in-game memory size, so to our RAM, because all these vertices, as I said, like GPU can render them easily, like high-end GPUs, but actually CPU needs to process them as well. So when CPU needs to process, it needs to put in the memory, and that's where trouble comes. Higher poly your mesh and more of these unique meshes you have, more memory you will use, and basically you will waste, because otherwise you could add more stuff, more unique stuff. And this is not directly shows how much memory you will use in your RAM, but basically try to have as low as possible. In my previous video, I already showed that, but I want to cover in this video, so it will be in all these optimization videos together. So we have nanites and we have fallback triangles. So keep in mind, this is totally different stuff, okay? So I was showing you here specifically, you see this gear, so I can toggle. So this is, I'm now in SM6 or DirectX 12, and this is in DirectX 11. And it's in DirectX 11, our Nanite's not working, and they are actually in UEFN automatic. And you can go into settings and platforms and choose which platform to preview. Okay, so keep in mind that, and in here in Nanite, so you can go in fallback target, set it to percentage. So in the Nanite and in a fallback, so this is our normal triangles, you can set a triangle count and let's say apply changes. And you can see that it's a big difference, but nothing is changed actually with my cube. Let's preview it with geometry better. And you can see that I'm in Nanite because it automatically changes like that. So we can go to Nanite fallback, and this will be our original geometry. Not very visible, maybe. Yeah, let's go this way. And reason it's not disabling that grid, but it's fine. I just removed skybox, so then we can easier see our topology. So you can see that, yeah, initially it was nice quads in there, but now it's quite messy, like that. But what it tries to do with our reduction, so it tries to remove where it's, again, it's not contributing to silhouette. So you can see that on the edges where it's actually contributing because it's making this edge rounded, it tries to keep it there, but then it tries to remove from the faces in here, flat faces. So let's say 25%. So you can see now easier that a lot gone from the center, but pretty dense still on the edges. And if we go in here, it still looks pretty good, all right? And we can go as low as we can until we'll see that it's, yeah, it's now starts breaking. And again, so from, I don't remember what it was, like 37,000, right? Now we're on 5.5. And our size, it was, I think it was like 1.5, 1.6 megabytes. Now it's 0.26. It's a huge difference. So now this mesh would contribute to memory on a much smaller size than, for example, it was before. So let's 5%. Still pretty good. And you see, like now, like this optimization, it works really, really good in Unreal and UEFN, even on a skinned meshes, animated meshes. And especially if you have, like in my case, I have just subdivided. So subdivision is basically add polygon by splitting existing polygons by 4. Yeah, so it's basically, if you have one polygon, it splits it into 4, and then the 4 into 4. It's basically multiplication. And topology is then pretty accurate, and for UEFN, pretty easy to optimize this kind of stuff. So you can see now it's really well optimized surface here, but it's still keeping all these edges. So it tries to help you as much as possible. But now we're on 1.8 thousands, yeah, triangles, comparing to 37,000. And again, we can see that on 100%, you see huge difference. And we can try maybe 2%. It will start breaking eventually, but even now, look, it looks pretty good. Yeah, there, you see like it starts breaking. And of course, this is a simple cube. It's much easier to do. If you will have some geometry with really complex shapes, then of course it will start breaking much easier. I usually trying to play around 30%, at least 50%, right? It's based on geometry. Some geometry not allows me to go even below 75%. It straight away starts to break. But even 75%, it's much better than 100%, right? So if always try to optimize your custom mesh as much as you can. Then on top of that, so we are optimizing, for example, this. So let's say we put it back on the 5%. So we optimize this. Yeah, it looks pretty good. So we optimize this, and we really a fraction of the memory we were using before. But we can go a little bit higher. So like, it's again, ignore that this is cube, but if you would have something more with more polygons, you want to do LOD. So you see, I have 3 LODs generated in here. If I will set it small, you see it's from 0.11, it even dropped to 0.08 megabytes, okay? Because what is LOD? LOD is basically your duplication of your mesh and then reduction of triangles from that copy. And usually it's a half of your each LOD. So next one is basically again half, next one is half. Sometimes it's more, but you can always preview how much. So I will show in a second. But let's say if you have really low amount of triangles, you can remove LODs and you will save your memory. So this is trade-off. Or if you want, you can add just fraction, as you saw, like pretty small number, but my cube is still on 1.8 thousand triangles. And this is pretty big for the cube. And what if I'm far away like this, and I have now next to this cube, now I can see on my screen 10 of these cubes. So then it 10's multiplied by 1.8, and it's pretty large number, right? So you should think about whole like picture, not just only one asset when you're optimizing. So then I'm okay. Maybe I will need, so usually I'm working with 2 or 3 LODs, and I can set to automatically calculate distance. And LOD group, it helps us to automatically set that properly. So based on the size of the mesh, usually I'm just like, you can play with all these presets. I usually playing just only with high detail, large prop, and small prop. And I'm just eyeballing. You need to try for yourself and what works for you. But basically, let's say high detail and large prop, you're telling that your prop is really large and that you need to be pretty far until it starts changing LODs, because otherwise it will be visible. And with a small one, you're telling to UEFN that it's pretty small one. I can be maybe already 2 meters away and I already won't notice when LOD will change. But then you don't need manually adjust that. I'm even sometimes playing manually adjusting that if I want more control. But again, this is trade-off. You sacrificing your time, but you making it more perfect. But let's say like it's a small prop, okay. So it generated me 4 LODs. As I said, I like to work usually around 3, maybe 2. Sometimes you may notice that it's not working really well because look on this LOD preview. So I should be inside even cube when it's in LOD 0 and really, really close when it's already on LOD 2. So we definitely want maybe it somewhere here start to change. So it's really too early. So it looks like this distance, automatic distance, is not working. So you can disable it like that and then go into each LOD and set size on the screen. So as you can see, LOD1 by default it's at 1.6, while on this distance you see it's a 0.45. So let's say maybe I will set it to 45, okay? And then in here it says for each LOD percentage, it's similar to this fallback triangles percentage, but in here it's for specifically for this LOD1. So you can always, again, if you have really high poly mesh and you already optimized it, but you won't sacrifice more on each LOD because again, LOD contributes to memory. So you can do this as well here. And sometimes it allows me to go even 25-30% instead of 50. But it's too harsh. You may notice like popping, right, when LOD changes. But yeah, so I will set this to 45. And then last one, maybe somewhere like this. So it's around 0.25. So let's say maybe even 0.30. Okay. Now let's set it to LOD 0 and we can see that it's working now much better. So in here it's LOD 0. Now we see it's switched to LOD 1 and we don't see even this popping, but difference is it's like twice triangle count. And now we're on LOD 2 and we're even smaller number. And now if we would have more of this geometry here around our more assets, it would be more optimized. So it's pretty good sometimes to adjust that automatically or manually. So always pay attention. It's not just press button and go. If you won't test, it may do something wrong for you. So on this, I want to finish this video. So hopefully that covered again what all this memory is, why we need to care about it, why we need really pay attention and test on different devices, especially low-end devices, and better practices for topology and optimization and these LOD systems, right? all this together. So hopefully this video will be helpful for you to work better and create more advanced levels. And in the next video, I want to cover more stuff around modular usage of the assets. So how we can reuse assets, why we need to reuse assets, how it helps to manage our memory that way, and yeah, and more stuff to come. Have fun. I would like to say thank you to my all supporters. I appreciate your support. Thank you for your generosity. You can join our growing Discord community, where we like to discuss UEFN tips and tricks, showcase our work, and help each other. You can find link in the description or in the channel header. You can get project files on my Patreon or just buy me a coffee to support me. If you're interested in learning more about UEFN materials, coding, widget UI, and more, feel free to subscribe and click that bell icon to get notifications when new videos will be released. See you soon.